what we're going to do now is we're going to use substitution, x equals 2 tangent of theta, where theta is in the first quadrant. And we're going to write the square root of 4 plus x squared as a trigonometric function of theta. Because right now this is a function of x, because it has x in there. So we just want to substitute x for 2 tangent of theta, simplify it, and then it's going to be now a function of theta. And basically when it just says a function of theta, it just means then that we're going to have theta instead of x in there. All right, so let's just first do our substitution. All right, so I'm going to substitute this guy in for x. Okay, so we'll do the square root of 4 plus, and then we'll do 2 tangent theta and then squared. Okay, so if I get rid of the parentheses by squaring, I'll have 4 plus 2 squared is 4, and then tangent squared is just going to give us tangent squared theta. Okay, this can actually be simplified even more, and check out this cool trickiness here. So both of these terms have a 4 in common, so I'm just going to factor out a 4. So it's going to be square root of 4, and then times 1 plus tangent square theta. Okay, look right here. 4 times 1 is 4. 4 times tangent square theta is 4 tangent theta. So this expression right here is going to be the same thing that's on top right there. Okay, does this look familiar? I hope so. Remember, this is one of our identities. 1 plus tangent square theta is the same thing as secant square theta. Okay, so I can replace this whole guy with secant square theta, because 1 plus tangent square theta, which is the same thing right here, is secant square theta. So the square root of 4 times secant squared theta. And now watch this. I can take the square root of 4 and I can take the square root of secant squared theta, because the square is the opposite of square root. So our answer is going to be 2 secant theta. And now it was a function of x, but now we have a trig function that's a function of theta.